All right, hello class. Again, lesson 5.5, and this is problem number 57. Basically, it just gives us an equation and asks us to solve it. But we have a bit of a problem because we have a sine and a cosine kind of mixed up together. And we also have a problem here with we have an x over 2 is one of the angles and just an x in the other angle. So one suggestion we can give it a try is why don't we try using some of these half angle formulas. It actually takes care of both problems. You can see the sine changes into a cosine, and also if we had x over 2 here, it would be x here. I'll show you what I mean by all that. Okay, so we're going to use this formula to replace sine, but actually the formula itself really is for sine squared, and we have a sine here instead. So I guess what we can do is just take the square roots of both sides, and we can say that that formula would actually be sine theta equals plus or minus square root 1/2 1 minus cos 2 theta. So that's actually the formula right there. So we can now apply that to our current problem. Okay, so let's plug this in. So we're going to let theta equals x over 2. So that's this part here and this part here. Okay, so this is going to be replaced with plus or minus square root 1/2 1 minus cosine. Now here's where the nice part is, because here we want to write down 2 theta. And so it should be 2 theta, but 2 theta, if theta is x over 2, then theta must be just x. So we have x. So that's good. It's all under a square root, and then we subtract cosine x and equals 0. Okay, very nice. So now it doesn't look that much better yet, but this is something we can solve. Let's put the cosine x on the other side. That equals cos x, and that allows us to square both sides. Okay, so we will square both sides, but be careful. When you square both sides of an equation, you run the risk of maybe finding some extraneous roots. So what that means is when we're finished, we should double check our solutions and make sure they're actually okay. Okay, anyways, when we square this one, the plus and minus thing, that doesn't really matter, because if it's plus and it gets squared, it's still plus. If it's minus and it gets squared, it's also plus. So just ignore this part. It's going to be plus regardless. And so here we're just left with 1/2 1 minus cos x. And that equals cosine squared x. Okay, now this is a little more friendly looking because it kind of looks like a quadratic. In fact, it is a quadratic. So let's just, let's see, multiply both sides by 2. 2 cos squared x, sorry. So I multiplied everything by 2 there. I'll just write that down so we can see what I did. Okay, and then let's put everything on one side of the equation. So 2 cos squared x plus cos x minus 1, and that'll equal 0. Now we can factor. So it's a nice quadratic. We're kind of into a regular equation that we're used to. So we can factor this thing. Let's see, it should be 2 cos x as one of the factors. The other factor will have cos x. And which two numbers? Well, I know they have to multiply to give me -1. So it must be a positive 1 and a -1. So where do they go? Well, you can double check this if you like, just to check. That should be the one that gives us 2 cos x. Let me see, 2 cos x, 2, yeah, that should be the one that works. Okay, so we have two equations now. Let me switch over to another color over here so I don't get mixed up. Let's see, so we have 2 cos x minus 1 equals 0, and we also have cos x plus 1 equals 0. Okay, so those are the two equations. There's 1, 2, and that's 1, 2. Okay. So what do we have here? We have cos x equals 1/2, and the other one says cos x equals -1. So basically we've got these two nice little equations, and that's a really good place to be, because now all we have to do is start thinking about our unit circle. And where on the unit circle do we have a cosine or an x coordinate of 1/2? Okay, so that's going to be up here. That's going to be an angle of, what is that one, pi over 3? Yeah, double check your unit circle to see if that's correct. And then down here as well also has an x coordinate of 1/2. So that one would be, let's see, 5 pi over 3. Okay, so just look I'm just looking at the unit circle to find which value. See, this has an x coordinate of 1/2 comma root 3 over 2 here, and this one was 1/2 comma negative root 3 over 2. Okay, and then so those two solutions come from this part, and this guy we're looking for x coordinate of -1, so that's out here. So that's when x equals pi. So basically that should do it. There's only 3 solutions. We're only looking in this interval from 0 to 2 pi, not including 2 pi. So our x value should be x equals pi on 3, comma, 5 pi on 3, comma, pi. So that should be our answer. But do you remember what I said earlier about squaring? When we square, we have to double check to make sure that we don't have an extraneous solution. And it even says in the question, use a graphing utility to verify your answers. So that's what we want to do. And I believe I've already got this in here so you can see it. Yeah, so here we go. I've typed the equation in already. That's sine x over 2 minus cos x. And I've graphed it. My window settings are starting at 0 here and all the way out to 2 pi. And wait a second, how many solutions do you see? You see 1, you see 2. But we wrote down 1, 2, 3 solutions down here. So one of them is extraneous. It's not correct because when we look at the graph, there's only 2 solutions. And if you do a little more digging with your graph, you can see that's pi over 3, that's 5 pi over 3, and the one that's missing, there is no solution at pi. So I'll use black for my final answer here. So the final answer is that one is extraneous. So therefore we have x equals pi over 3 and 5 pi over 3. That's the only answers. Those are the only answers, I should say. Okay, awesome. So we got it. We weren't tricked by that extraneous root, and everyone's happy. Okay, enjoy.